All right, so here we go, lesson 9.2. You should be able to graph polar equations. So far, you know how to graph circles and limicons. Today, our primary focus is roses. With the circles and limicons, we made a few observations that if it opens above or below the pole, it is a sine theta function. And if it opens to the right or left of the pole, it is a cosine theta function. We noticed that the symmetry for any sine function was the radial pi over 2. Theta, the line theta equals pi over 2. And for this, it was the polar axis. And so that allowed us to narrow it down. Instead of having to find all values from 0 to 2 pi, what can we do when it's cosine? We start where? 0 radians to what? To pi, actually, if it's a limicon. If it's a circle, you might be able to get away with less. Okay? And then we were able to reflect across the polar axis. So that would give you half the graph, finding those values reflected across the polar axis. For sine, instead of finding all the way from 0 to 2 pi when it's a limicon, we can do from negative pi over 2 to pi over 2. Some of us didn't want to use those negative values, so we just said we'll use these values from 3 pi over 2 up to 2 pi in quadrant 4 and the quadrant 1 values. But then when you get half of that graph, you reflect it across the radial theta equals pi over 2. So that was our summary from yesterday. Now, yesterday you also made some notes about these. When am I going to have, when am I going to have like a lot more than what I see in the equation? When it's even, when the multiplier on theta. So what we're going to look at this is r equals a times cosine, or actually trig, because it might be cosine or sine. If it's cosine, okay, so trig function of n times theta. Well, if n is even, in both these cases on the left, n is even. On the cases on the right, n is odd. So you notice that instead of having 4 petals, it actually has 8 petals. Instead, on this one, instead of having 2 petals, even though n equals 2, there are 4 petals. And there's some asymptotes. It's really hard to get the asymptotes in here. Here it's a little more easy to see. See how they're coming really close to the polar axis, and theta equals pi over 2. Those are like coming right up against it. Here that's not the case. If you look and you're like, oh, look, that's halfway between. Those petals aren't really approaching that. They're actually approaching this line and this line. Well, maybe not. It might even be closer than that. I'm not sure. We'll have to figure that out in a little bit as we start to look at asymptotes. Also, what about the length of the petals? Where does that come from? A. The length of the petal is A. So in this case, it's 2 radial units long. Here the radius is 1. It's 1 out. Here it's 3. So we see 1, 2, 3 is the farthest length on the petal. That's the maximum length on the petal for each of the petals. There's some tricks to graphing these so that we don't have to plug into the calculator. You can plug them into the calculator, but it's going to just give you numbers, and then some of the numbers are here and some are here, and it's going to be hard to make the actual petal if you don't follow the rules for it. So we already know the number of petals. When we have a function a times r equals a times trig function of n times theta, whenever you see that multiplier on theta, then you know it's a rose. Some of you already figured that out on the back because you knew which one of these were circles versus lines versus circles versus limicons. And this would be a rose because of the multiplier on theta. So some of you had already figured that out. With our number of petals, though, if n is even, then we have to do 2 times n equals the number of petals. and the number of, well, we'll talk about that in the symmetry, and the number of asymptotes that we need to find. In terms of the whole radial, it's due to symmetry. There's actually more, but due to symmetry, that's all we need. If n is odd, then n is the number of petals. Of course it did. Did this earlier too. Hold on. There we go. Then it is the number of petals. But the asymptotes are going to be 2 times whatever n is. I think that's right. I think here if we find n asymptotes, we're actually good because of the symmetry. There's going to be more than that, but just finding n of them will be enough to graph. All right, our lengths of the petals, we already said, comes from the value of a. You set the radius will just be a. You can drop the trig function, it's the value of a. And symmetry, if it's even, then it'll be symmetric. They'll all have rotational symmetry, except if it's even, then your asymptotes, you can just draw a whole radial, you'll see. Asymptotes, full radial line will get you both as opposed to just one. If it's odd though, then you have to do the asymptote from the pole toward the outer circle. I'll show what I mean by that in a second. So what's going to happen is if we have even, actually we have a graph of it right here. When we had even, I could just do this radial right here, and I just went right across. In reality, there are 2. There's this radial, or this angle right here, and this angle that are both asymptotes, but they're really the same line. So just by connecting it straight through, because of symmetry, I'm good. I don't have to do extras. And I can cross through there and just do the other side. But if I'm looking at an odd one, I can't do that. I have to start at the pole and go over. Actually, might be able to. I don't know. We'll figure it out, but there's going to be several locations for those. So we'll take a look at those. All right, graphing each equation. When you go to solve this, what's the maximum length for our petals? For this one, well, first off, how many petals are there going to be? There's going to be 3 petals, because n equals 3. There are 3 petals. But what's the length of them going to be? 2. So what I'm going to say is that r equals 2 at the petal tip. So what I'm going to do is plug in 2 for the radius. So I'm replacing r with 2 equals 2 cosine 3 theta. What's this going to help me find? Theta. Yeah. Knowing the radius. Hey, I'm saying we want the radius to be 2. Tell me when the radius is 2. What value of theta is at which values, and there should only be 3 of them, is the value of 2 theta? Is the value of theta? What value will give us 2 for the radius? So when I go to solve this, I'm going to divide by 2, and I've got 1 equals cosine 3 theta. Well, now I've got cosine equal to 1. This means that 3 theta equals something. However, I need how many petal tips? 3. So I'm going to put 3 spaces. When is cosine 1? Only one place on the unit circle. 0. Cosine is 1 at 0. That's a bit of a problem for us because we need 2 more answers. Well, what we're going to do is we're going to add 2 pi. We're just going to get all coterminal till we fill all the spaces we need to fill. So we're going to do this. We're going to add 2 pi. So this becomes 2 pi. To that, we're going to add 2 pi. So this becomes 4 pi. And some people are like, well, that's the same exact spot on the graph. But we're going to have to divide by 3, so it'll be okay. So to solve for theta, we're going to divide by 3. This will give us theta equals 0 over 3, which is 0 radians, 2 pi over 3, and 4 pi over 3. Those are the locations where the radius is 2. So I really have 3 points. 2, 0, 2, 2 pi over 3, 2, comma, 4 pi over 3. So I can plot those. I'm going to put it 1. Actually, I'm going to make this 1 and this 2, since that's my max point anyhow. 2 pi over 3 is here. 4 pi over 3 is down here. So there's the tips of the petals. Now for the asymptotes, I guess I should have written that up here. To find the petals, we're going to set, hold on, I'll make a note down here. Finding petals, I want you to have a note somewhere. Finding petals. If it's odd, if n is odd, then you're going to set equal to a. A equals a trig function and theta. If n is even, then you're going to do plus or minus a equals a times trig of n times theta. That's going to be finding the petals. To find the asymptotes, we're not going to set it equal to a, we're going to set it equal to 0 and solve. Yep. We will. Hold on. We do 2n, but not inside the trig function, not when we're going to solve. So if we're solving for location, that's how we find the locations. I didn't have much room at the top. I don't know if you knew, so I wrote it down here. Finding the petals, we just did this when it was odd. We said, hey, the max length is 2, so we set r equal to 2, and we solved the trig function. Then we solved for theta, and we were able to plot it. If it's even, though, we're going to have to do plus or minus. You'll see why in a second. It has to do with the symmetry. And then the same thing, though, to find the asymptotes, we set it equal to 0, the trig function equal to 0. Yes, doesn't it, right there? Yes. Oh, it should. A times trig, yes.
So they're the
Same equation for all of them. It's just if you want, for odd, if you want the petal tips, you set it equal to A. For asymptotes, equal to 0. If it's even, for the asymptotes, plus or minus A. For the petal tips, sorry. For the asymptotes, set equal to 0. So on this one up here, we're going to find the asymptotes now. So I'm going to do 0 equals the 2 cosine of 3 theta. What's going to happen to the 2? We're going to divide by it, and 0 divided by 2 is still 0. So 0 equals cosine of 3 theta. Well, cosine is 0 in 2 places. Pi over 2 and 3 pi over 2. However, how many spots do I need to fill? Careful. 6. When it's odd, right, we said when it's odd, the number of petals, the number of asymptotes is 2 times n. So I actually have 6 spots to fill. And we'll look at it. Hold on. So 3 theta gives us, for 0, when cosine is 0, you guys said was pi over 2 and 3 pi over 2, right? But now I need 4 more values, so I'm going to take to each one of these, I'm going to keep adding 2 pi. So to the pi over 2, I'm going to add 2 pi. It gives me 5 pi over 2, because that's plus 4 pi over 2. I'll have to do that again to get, I'm going to skip one more to get to the next one. If I add another 2 pi, I'm going to get 7 pi over 2. 5 plus 4, yes, sorry, I did the next one. It would be 9 pi over 2. This one, if I do 3 pi over 2 plus 4 pi over 2, gives me the 7 pi over 2. So you can see we have 1, 3, 5, 7, 9, 11 pi over 2. I'm going to, instead of dividing by 3, I'm going to multiply everything by 1/3. That gives me my actual petal tips. Not petal tips, I'm sorry, asymptotes at pi over 6, 3 pi over 6, which is pi over 2, 5 pi over 6, 7 pi over 6, 9 pi over 6, which is 3 pi over 2, and 11 pi over 6, which thankfully are on our unit circle. They're not always going to be. You'll see that one in that horrifying moment in a second. All right, so we have these, and we're going to do, so at pi over 6, which is right here, I'm just going to do an asymptote from the center that way, or from the pole out toward it. I did that one. Now I have to do 3 pi over 6, which is this one, 5 pi over 6, which is this one, because I have my unit circle in front of me. 7 pi over 6 is this one. 9 pi over 6 is 3 pi over 2. And 11 pi over 6. This one had some symmetry with them too. If I had found 3 and extended them, I would have been okay. So I could have just found the first 3 and gone this way. It would have saved me a little bit of time. When I go to graph this, I have to connect the point to the pole and go very, very close to the asymptote without touching it. Nope. I don't have to use my calculator for roses. I might have to when I'm calculating some of this stuff if it's not on the unit circle. If it's on the unit circle, it's very easy to graph. If there are values that aren't on the unit circle, it becomes a pain in the butt. But it gives me a sketch. It's not super detailed. If I wanted more detail, I'd make you do a table, but I don't really care. So you don't have to have every specific angle. It's going to be a little bit different. Any questions on this one? How we got the tips of the petals or how we got the asymptotes? Yes, Kristen?
How did you get pi over 2 and pi over 2?
Pi over 2 and 3 pi over 2. When is cosine 0 on our unit circle? Cosine is 0 at pi over 2 and 3 pi over 2. So that's what 3 theta was equal to, pi over 2 and 3 pi over 2. And then I kept adding 2 pi to those values to keep getting the next numbers till I filled all my spaces. And it looks like we could have just found 3, and it would have been okay because of the symmetry. So if you want to, you could just find the first 3 and just go straight across that radial, and it'll work. All right, let's take a look at letter B. How many petals should this one have?
4.
Since n is 2, there are going to be 4 petals. And the radius of each one of those is going to be 3. So what I'm going to do is I'm going to set my radius equal to 3. But I have to do, because it's even, I have to do, what? Sorry, what did you ask? I'll keep it there. I'll put it in the equation. I don't have to worry about it right now. Because it's even, I'm expecting 4 petals, not 2. So I'm going to do plus or minus 3. How is that going to give me more petals? Let's think about it for a second. How many answers did you get for this when it was equal to 1 value? How many from the unit circle did you get? No. You got 2 and you added 2 pi to get the third one, right? Here, if I want to get twice the number of petals, by putting the plus or minus, I'll get those other values as well. So we'll take a look, you'll see in a second. So we've got -3 sine of 2 theta. Sort of what happens when you divide by the negative. Well, then it becomes minus plus, right? It was plus or minus 3. Now I've divided by -3. It's minus plus. Does it really matter? No, it's the same thing as plus or minus. It doesn't, I'm just saying, if it was positive, then that one's now negative. If that one's negative, now it's positive. It wasn't meant to be funny. All right, so where's sine 1 and -1? By the way, how many answers do we need for this? How many answers do I need? 4 for 4 petal tips. It's at 0 and, wait, sine is not 1 at 0 and pi. Sine is 1 at, I'm not looking for asymptotes. Sine is 1 at pi over 2, that's okay, and 3 pi over 2. How do I get the other two values? Add 2 pi. Add 2 pi to this first, which is 4 over 2, so that becomes 5 pi over 2. Add 4 pi over 2 to this, that becomes 7 pi over 2. Yeah. Now what do I do? Can't put my dots on yet. Multiply by 1/2. So my thetas are actually pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And I'm supposed to go out 3 units because that's the radius. So 1, 2, 3, there's a point. Here's a point. Here's a point. Yes, and here's a point. That should kind of make sense, right? We got 2 pi and we're dividing it, putting 4 petals in there. We've got those 4 petal spots, right? Now, our asymptotes, some of you already know where they are. To show how they could be calculated, though, we set it equal to 0. When you divide by -3, you're still going to be 0. We're saying when is sine 0? Well, sine is 0 at 0 and pi. Well, I'm supposed to have 4, so I'll get them, but honestly, you'll see why we don't need it in a second. If I add 2 pi to 0, I get 2 pi. If I add 2 pi to pi, I get 3 pi. Dividing by 2 gives us 0, pi over 2, 2 pi over 2, and 3 pi over 2. Well, what do you know about the line pi over 2 and the line 3 pi over 2? They're really the same line in the polar coordinate system. So there's an asymptote, and there's an asymptote. Now, notice for these, it wasn't exactly between the two coordinates, so you got to be careful on the odd. That wasn't right in the middle of them. In the even, though, it really is at the middle angle between where the other two are located. Not true for odd, but it is true for even. So then this comes in close toward that asymptote. I could actually make these a little fatter than I did, but they have to touch at the pole. And there's my rows. See if you can find the petal tips and asymptote locations for C and D. You don't need to graph them yet. Just see if you can find their locations, and then we'll talk about graphing them. I'll be right there. So if you should have gotten, when you have set this equal to 4, and there are only 5, so you had 5 spaces, that sine equals 1. When sine equals 1 at pi over 2, you kept adding 2 pi to it to get all 5 petal tips. Dividing by 5 or multiplying by 1/5, then you got these values. Here comes the fun part. Our unit circle is not divided into tenths, so it might be helpful to just have a regular old circle graph with the axes, or some really good colors that'll help you do what we're about to do. I'm not so good with splitting this pi units into 10 equal units, or even not this into 5. So what I'm going to do, some of you might be good at doing that, but the lines throw me off. So I'm going to actually convert pi over 10 to degrees, because I think that will help me think about where the degrees would be. Pi over 10 times 180 over pi is 18 degrees. So really this is 18 degrees. I'm just going to keep adding 18. This is 36 degrees. This is 54 degrees. I had the unit circle can help me out there because I know it should be a little to the right of this or a little to the left. Keep adding 18. This one's 72 degrees. Wait, that's not right. That's not, I didn't do that right. That's where I'm going to put my lines. Hold on. If this is 30, this is roughly 18. Guess what? I don't want to do this all around the circle, so guess what I'm going to do? Make a line to get the other side so I don't have to add those ones later. So there's my 18 degrees, or pi over 10. Then I have 36. Since this is 30, I'm going to go a little past it for my 36. So that's going to be 2 pi over 10. My next one, if I keep adding 18, is 54. So now I go to 54 degrees. That's just under 60. And this is a sketch. If it had to be more accurate, I'd have to actually get a protractor out and do angles and all that stuff. We're not doing that. We're sketching. So this is 3 pi over 6. I add 18 again, I get 72 degrees, which is beyond 60, actually a little higher up. So here's my 72 degrees, or my 4 pi over 10. Good news, what's 5 pi over 10? Pi over 2. Yay, that's one of our lines. Now I'm going to come over here. Some of you will just reflect these points. That's fine. You could just keep adding 18. My next one's 108. So there's my 5. This is my 6 pi over 10. Add 18 again, I get 126. I could also just reflect this point to right here. Yikes. There's 7 pi over 10. Add 18 degrees again, I get 144. I know where that is. Wait, isn't this 150? Yeah, 150 is there, so. There's 8 pi over 10. Add another 18, I get 162. Connect them back to your pole to get your radial. There's 9 pi over 10. So there's my radials. It's a little ugly. They're not as evenly spaced as I would like, or they don't look it because of the other lines that are in there. But I can count my blue lines. Yes?
Why are you putting all those different lines and radials in?
Because these are split. These units are in tenths. So by doing tenths around the whole circle, I now have 20. From here all around makes 20 radials, not if I don't count the ones that were originally drawn there. And I do have this too. This is 10 pi over 10, and on the other side it's 20 pi over 10. So now I can actually go through and plot. We're supposed to go out 4, so that's good. We're going to come out all the way. Pi over 10 is the first one. 5 pi over 10 is the second one. 9 pi over 10 is the third one. 13 is the next, so 10, 11, 12, 13 is here. 17 is the next one, so 14, 15, 16, 17 is here to get my points. Now that I have my points, I need my asymptotes. So I've got 0 equal to 4 sine of 5 theta, which means 0 equals sine of 5 theta. Sine is 0 in 2 places. It's at pi over 2 and 3 pi over 2. But I need 5 of these things, and I'm going to reflect them across. Technically, I should have 10 of them, but I actually can just travel right through on the same line, and it'll be okay. That sine is 0. Oh, yeah, I was thinking of cosine. It is 0 in pi. Thank you. That saves me a lot of work and from having to redo it all. So then this becomes 2 pi, 3 pi, and 4 pi. Because I got 0 plus 2 pi, 2 pi plus 2 pi, pi plus 2 pi. Now I have to divide. This is what 5 theta is. So I have to divide by 5 or multiply by 1/5. I do need 10. But when we noticed this, right, when we went to graph all of ours up here, we had 6 of them. After we graphed the first 3, when we graphed the 4th and 5th one, we realized that they were on the same radial as the other ones we already had. So we could just go right through. We didn't have to think about them. So I'm trying to save us time. We don't have to think about all 10. There are 5 more, yes. So technically, I should list them. But for sketching the graph, if I have 5, I'll be OK. Does that make sense? So if you go to Calc next year and Miss Lambert asks you, what are the asymptotes? There are 10 of them. You should list all 10. Huh? Well, no, but there's always 2 more, right? Look, they're close. There's more radials on this. 1, 2, 3, 4, 5, 6. Here, there's 4, but here there's more. There's more on an odd graph. It's not halfway between the 2 points. It doesn't open up wider. The ones that are odd are narrower roses. These ones are fatter roses, the even ones. So now we're going to plot these, although you might want to think about them in terms of tenths. 0 is easy. And instead of finding the next one, which would have been, right, it would have been over here. Pi over 5 is 2 pi over 10. Here's 2 pi over 10. So pi over 5 is 2 pi over 10. So now I can just take my marker and from the center in here, open toward the radial. There's my first petal. If I pay careful attention to this, see how this was the next, these are all in tenths. This was the next one from where my point was. So if I look at where my point is, here's going to be a petal, and here's going to be a petal, and that actually makes sense because this would be 4 pi over 10, which that point is. This would be 6 pi over 10, which that point is, or actually that line, I should say. So now I'm going to trace those radials. So now this point gets close to that. See, it's not one asymptote between the 2 petals, but rather 2 asymptotes between the 2 petals when it's an odd one. And now I'm going to trace these 2, or this last one, which is 8. So there's 8 pi over 10. And then obviously this one again, which we already had from 0. So now I just go from that point to the pole, from this point to the pole, from this point to the pole. And I have all 5 petals. Any questions on that? All right, see if you can find real quick where your petals will be for this one, and I think you'll get the asymptotes even quicker. There are 5 more asymptotes, but for the sketch, I've got enough by just having 5 of them on this one.